Okay, good morning, Professor David J. Delos Reyes. Okay, it's September 29, 2023. The time is 4:28 a.m. Okay, good morning, guys. Let's have a coffee. Okay, my topic for this session will be college algebra, and I am now on lesson number 76. We are almost done with college algebra. Okay, let's proceed. The subject matter for this morning will be college algebra, lesson number 76. Okay? Well, we are almost done with college algebra. I'm just presenting the different variation of problems involving linear equations. Okay? Because for every type of problem, the concept is different. So, the concentration of the subject matter is actually on the concept, and I will give you example problem to visualize the concept. Okay, let's proceed. College Algebra, lesson number 76, application of linear equations under the subtopic work problems. Okay, the variation of problem under linear equation is work problems. We are done with the distance problems. What's next? Hmm, I forgot the other one. Oh, forget the other one. Distance problem. And for this morning, it will be the work problem. The concept for every type of problem is different. So the concentration of the topic is on the visualization of the concept and will provide you an example problem. For work problems, the concept are only two. Okay. Rate of work is equal to the reciprocal of the time needed to do the entire job. Oh, as simple as that one. Like for example, if you could finish painting the job in 2 days, if you take the reciprocal upon that 2 days, that one half is actually represent the part of the job that is done. Of course, one half plus one half will be one, and one is actually equal to complete job. So according to the rate of work, it should be the reciprocal of time. Okay, next. The work done is equal to the rate of work or speed of work times the length of time. Right? Like, for example, if you finish doing the job in 2 days, okay, and your rate will be 1 over 2, right? So the work done will be 1 half times 2, and 1 half times 2 is actually equal to 1, and that's the complete job. As simple as that one. Okay, let's bring out an example problem. Uh, Peter can clean the house in 1 hour and 40 minutes, while John can clean the house, same house, in 2 hours and 30 minutes. The problem is how long will it take them to finish cleaning the house? The given condition is they must have to work together, right? So we are given the first man here, Peter, and he can finish the job, cleaning the house in 1 hour and 40 minutes. And the next man is John. Where's John? This is John. And he could clean the house in 2 hours and 30 minutes. The problem is asking if they work together, how long will it take them to clean the house? Okay? Oh, this is a logical problem. So, to better understand the translation these to algebraic equations, okay, we needed the two concepts that I discussed over here. That is the rate of work is just the reciprocal of time, and the work done is the rate of work times the length of time. Okay, let's try to bring out the solution. For the solution, we need a representation here. There is only one unknown over here. We represent that unknown by x, and this will be the total time for both to clean the house. if they work together, okay, this X here represents the time that they will take together, they will work together to finish cleaning the house. Okay, let's try to bring out the data for Peter. For Peter, the time for him is 1 hour and 40 minutes. This is the cuts over here because the given time is in terms of hour and minutes. So to simplify calculation, we should convert the hour to minutes. So we will represent the time for Peter to do it in minutes. So 1 hour and 40 minutes, 1 hour and 60 minutes plus 40 minutes. A minute and a minute, we could add it, right? They are of the same nature. So 60 plus 40. For Peter, the total time for him to clean the house will be 100 minutes. For John, T is equal to 2 hours plus 30 minutes, right? So converting these hours here to minutes, so we could add it to 30 minutes. We know that 1 hour is 60 minutes, so this should be 2 times 60 plus 30. This is now minutes, this is minutes, so we could add in, right, algebraically. 120 plus 30, and the total time for John will be 150 minutes. It is longer by 50 minutes. Of course, his is slower, right? Let's try to bring out again the data for Peter. The speed. The speed of Peter, or the rate of how Peter do the job. I will just simplify the designation speed of work of Peter. According to concept number 1, the rate of work is actually the reciprocal of time. So if the total time Peter do the job is 100 minutes, his speed is actually 1 over 100 per minute. This is per minute. Okay, right? The rate is 1 over 100 per minute. Okay? Meaning to say, to finish the job, he must have to do it in 100 minutes for this to be 1. For John, it's the same. We'll just take the reciprocal of his time. It is 1 over 150 per minute. Right? Because for John to finish the job, he must have to consume 150 minutes. For this to become 1, okay, he must have to work 150 minutes. Okay, let's try to translate the given worded problems into an algebraic equation. We'll do it like this. A portion done by Peter, or the work done by Peter, plus the portion done by John, or the work done by John, should be equal to the complete job. Or as simple as that one. Okay? Have you got it, guys? The work done by Peter plus the work done by John should be equal to the complete job. Okay, that's our translation of the worded problems, right? So the portion done by John is actually the rate of John times the unknown time, and the portion done by John, Peter, the first one. The portion done by John will be the rate of John, which is 1 over 150, times the unknown time. Okay? And this should be equal to, the right hand side should be 1. Why 1? 1 is 100% already. You finish the whole job, right? So the right hand side will be 1. Okay? So after the substitution, if we try to look at it, the resulting equation is actually a linear equation. That's why our topic for this morning is application of linear equations. And this is under the subtopic work problems, right? Okay. So by using these two concepts here, we derive this linear equation and to solve for the unknown. Okay, we pass by the solutions of system of linear equation already, right? So it will just be simply by using our knowledge of fundamental operations and simplification Okay? And that's it. So if we try to simplify this, this is now under the shorts videos, right? There's a common factor x. Am I still on camera? We bring it out. So the first fraction is 1 over 100. Next one is 1 over 150, close quantity, and this should be equal to 1. The only unknown is x, but we must have to simplify these two fractions here into a single fraction so we could compute for x. X now will be equal to, like what they are doing in the short videos, di ba? Butterfly method, right? The product of 1 times 150 will be 150. The product of 1 times 100 will be 100. And the resulting denominator will be the product of the denominators. Okay, butterfly method, guys. Short videos, right? We are saturated with that one, right? So what will come out? X now will be equal to this 15,000 will be multiplied by 1 because the right hand side is actually 1 over 1, right? So if we try to simplify this one, we cross multiply. The product of 15,000 times 1 will be 15,000, and the product of 1 times the quantity x times the sum of these, if we try to compute for x, x now will be 15,000 over 250, right? The coefficient of x is 250, so to compute for x, we must have to divide both sides by 250. So x now will be 15,000 over 250, and x will be equal to 60 minutes. The answer is 60 minutes. The time for them to work together to complete the job will be 60 minutes. I think it's just more than reasonable enough. Because for Peter, 100 minutes, and for John, it's 150 minutes. So if they try to work together, it should be between 100 and 150 minutes. And this 60 minutes is actually, no, it should be less than the lesser one, right? Because they work together, right? So 60 minutes is less than 100. They should be correct. Okay, that's how we solve problems under linear equations involving work problems. Okay, good morning from Los Angeles, Professor David J. Delosreyes.